So the Pythagorean theorem is a theorem that we use when we talk specifically about when we're working with right triangles. So if we're looking at a right triangle and we're dealing with the Pythagorean theorem, we're looking at A and B being the legs of this triangle, and C is the hypotenuse of the triangle. So the Pythagorean theorem states if I take the two legs and I take the sum of their squares, so a squared plus b squared, that'll equal the hypotenuse squared. And we can use this to solve for different pieces of the Pythagorean theorem. So let's look at some examples. When we're looking at a triangle, we simply want to start by labeling our pieces. It's helpful to do that. So our legs are going to be the two sides of the triangle that make up the 90-degree angle. So these two. It does not matter which one of these is A and which one of these is B, as addition is commutative. Okay. Our hypotenuse will always be directly across, the side directly across from the 90-degree angle. Okay. Now we're simply going to apply the Pythagorean theorem. So it says a squared plus b squared equals c squared, and we want to go ahead and substitute in our values. So that would be 4 squared plus 8 squared equals c squared. Okay. 4 squared plus 8 squared is 80. Now, I don't want to know c squared. I want to know what c is. So in order to find just c, we're going to do the inverse operation of squaring, which is square rooting. I'm going to take the square root of both sides. And then you want to simplify your square root. So c squared, square root of c squared is just c, right? So square root and square, we can think about those as inverse operations, just like addition and subtraction, very similar. And then when we simplify a radical, I'm going to do this off to the side. You can also just do this in your calculator. When I simplify the square root of 80, we can apply a couple of properties. So first off, I want to break this into a perfect square piece and a non-perfect square piece. So I can rewrite this as the square root of 16 times 5, right? So 80 is 16 times 5. Now, square roots are allowed to be broken up when we're dealing with multiplication. So I can rewrite this as the square root of 16 times the square root of 5. And then the square root of 16 is a perfect square, right? So square root of 16 is just 4 times the square root of 5. So this would be our final simplified radical. But if you're using a calculator, most scientific calculators will simplify radicals for you. But you want to make sure either way, simplifying by hand or simplifying with a calculator, that your answer is in the most reduced form. So we would have our C value is 5, oops, excuse me, not 5. It is 4 times the square root of 5. Okay. So we're not going to be using any decimals. We're going to leave these as just reduced radicals so that we have an exact value. So let's do our next one. So I'm going to label my two legs, A and B, and label my hypotenuse. Okay. Then we'll go ahead and square our legs and take the sum. So 6 squared plus 5 squared equals c squared. So that'll be 61 equals c squared. Take the square root of both sides. Now, the square root of 61, that does not simplify any further. It is simply the square root of 61. Now, if you wanted to rewrite this, it's instead of square root of 61 equals c, it's c equals square root 61. You can, but that's up to you. Okay. So now let's go ahead and work with this, but on a coordinate plane. So we have 2 points here. And we want to be looking at sort of using this Pythagorean theorem and doing something very similar, but with these 2 points. So what we can do is kind of create ourselves a triangle. We can connect these 2 points, and then we can go ahead and just like we would do for slope, kind of create this triangle right here. Now we want to go ahead and look at our sides. We can find the sides of these triangles. And we can find it in one of 2 ways. First way, we can just count. right? So this is 1, 2, 3, 4, 5, 6 units. Or we can kind of think back to when we were working with a linear distance. So if we're thinking about the coordinates, right here, the x coordinate is -2, and right here, the x coordinate is 4. So if I want to take the distance between those two values, we would do the absolute value of -2 minus 4, right? Which is the absolute value of -6, which is just 6. And let's double check that. 1, 2, 3, 4, 5, 6. Yep, that works. Now, this distance piece here is going to come in handy later when we talk about the distance formula in a couple minutes. Okay, so I have my two legs. They're both 6. So we're going to go ahead and apply the Pythagorean theorem. 6 squared plus 6 squared equals c squared. Okay, so that's 36 plus 36 equals c squared, or 72 equals c squared. Taking the square root, we would find that that is 6 times the square root of 2 equals c. Okay, we're just going to do this last one here. So when we connect these 2 points, we'll notice we can't really form a triangle because it's simply a horizontal line. So at this point, we actually don't really want to use the Pythagorean theorem if we're looking at something like this. What we can do is just apply the kind of the formula we used for just distance on a number line. So if you look at your 2 coordinate points, so we're going to have the coordinate point 3, 5, and then the coordinate point 3, -2. We can see here that we're going to be having a distance in kind of the vertical direction. So our horizontal value, right, our x value didn't change, but our y value did. So that's what we're going to use to find our distance, or you can just count. So if we're applying that kind of idea of distance just on like a number line, or not sort of on the diagonal of a triangle, we can just take the absolute value of the difference of those two values. So 5 minus a -2, and we're taking the absolute value because our distance is going to be positive. So that's the absolute value of 7, which is just 7. So my distance here would be 7. So let's take a look then at the actual distance formula. So what we're doing here is using the Pythagorean theorem, but we're using the fact that when we build a triangle on the coordinate plane, we're really kind of taking the difference of two values. So let me sketch this real quick for you. So if we had a coordinate plane and we have 2 points, okay, and this is going to be x1, y1, and this guy is going to be x2, y2. When I create my triangle and I look at my sides, my vertical distance here is really the difference between my y values, right? So up here we're at y1, down here we're at y2. So this distance is the difference between those two values, right? y1 minus y2, the absolute value. Okay. Now this horizontal distance here, right, that's parallel to our x-axis, that is going to be the difference of our x values, absolute value x1 minus x2. Okay, so that's how we're going to find those side lengths. So if I'm looking at the Pythagorean theorem, I can say, oh, well, this is really just my A, and this is really just my B. Okay, well, that's awesome. So we're going to do one thing here with the Pythagorean theorem, which is we're going to take it and we're going to quickly just solve it for C. So the way I'm going to do that is I'm just going to take the square root of both sides. We're going to get the square root of a squared plus b squared equals c. And I'm going to quickly rewrite that. So c equals the square root of a squared plus b squared. Okay, now this brings us to the distance formula. So we're going to combine what we know about the Pythagorean theorem and then also what we know about kind of what's happening on this coordinate plane, and we're going to create the distance formula. So the hypotenuse on the coordinate plane is really the distance, right? So this is really the distance between the 2 points. So when we're working with the distance formula, instead of using C, we're going to be using D because we're talking about distance. Now, in the Pythagorean theorem, we looked here and we said, okay, well, when we're solved for C, we have the square root of a squared plus b squared. All right, let's look at A. On our coordinate plane, we said A is really just the difference, the absolute value, between the difference of our y values. Okay, well, I'm going to plug it in here. So that's y1 minus y2. Now I can drop the absolute value because I'm going to be squaring this number. And anytime we square a number, we're always going to get a positive end result, right? Because squaring a number is just multiplying it by itself. So a positive times a positive is a positive, and then a negative times a negative will give us a positive. So we don't have to worry about the absolute value when we're plugging this into the distance formula. Okay, and last piece, we said B is just the difference between our x values. So that's x1 minus x2. And now we have our distance formula. So how are we going to apply this idea of the distance formula? What are we going to use it for? So we're going to make use of this distance formula when we're given 2 points and we don't really have a grid to be working on. So we're just going to go ahead and directly apply this Pythagorean theorem. So it's sometimes helpful to label your values. So we have an x1 and a y1 value, and an x2 and a y2 value. And all we need to do is simply plug that directly into our formula, and then it's just a plug and chug calculator problem. So our distance is going to equal the square root of the whole quantity, 1 minus negative 7 squared plus, so now our x value is negative 2 minus 3 squared, right? So you can just plug this whole thing right into your calculator and get a value. I'm going to do it a little bit longer just so you can see it worked out. So 1 minus negative 7 is 8, so we're going to have an 8 squared plus negative 2 minus 3 is a negative 5, so negative 5 squared. Especially when you're dealing with negative numbers and you're squaring it, it is very important to leave it in the parentheses, because if we're looking at negative 5 squared in parentheses, that's 25. But if we have negative 5 squared out of parentheses, this is actually telling you to square the 5 and then take the opposite. So this value is actually negative 25. So you just need to be very careful. This is especially going to affect your answer if you're plugging this into a calculator and you're not using parentheses. Okay, so we're going to keep going. So this is the distance is then equal to the square root of 89, which we can't simplify any further. So let's go ahead and do a couple more of these just to get a hang of them and see what they look like. Okay, so next up, we got negative 4 and 3, 5 and 3. So that's x1 and y1, x2, y2. So the biggest thing here is just to make sure that you're plugging it into your formula correctly. The rest of it is the calculator's job for the most part, unless you prefer to do your calculations in your head. So we're going to have the distance is equal to the square root of, so the difference of our x's or our y's doesn't really matter because there's addition in the middle there, so we don't care which comes first. Okay, so I'm going to do my x's. So that's negative 4 minus 5 squared plus 3 minus 3 squared. All right, so then that's the square root of 9 squared plus 0 squared, which is the square root of 81. And the square root of 81 is just 9. So make sure you're simplifying. Okay, last one. This one I'm not going to go ahead and do those intermediate calculations that you're probably just going to have your calculator do. Okay, so our distance is going to equal the square root of the difference of our x's, 8 minus 5 squared, plus the difference of our y's, 4 minus -1 squared. Go ahead and throw that into your calculator. You're going to get the square root of 34. So again, make sure you're not rounding. Make sure you're just using your most reduced radical form so that you're leaving your answers as the exact value.